Alright, so it's like the recording had started. So let's go over today's topic, that is the distributed database management systems. So here is the popularity chart that I just pulled up, that gives you what database models are currently in the industry. Looks like the Oracle and MySQL are the ones that are top-notch. No surprise there. And they use the relational database model. That's the conventional, and the SQL queries that you write every day. That is what is being used, but the network architecture behind those is what matters, because Oracle and MySQL are cloud-based systems. So cloud-based makes them maybe distributed database management systems, or maybe some other architecture which I'm not aware of, but current topic is the distributed, so let's quickly jump into that. So the companies that currently use distributed database, so Apache Cassandra is a distributed database management system server that is developed at Facebook, and being used by all these companies, most of which are pretty popular and famous. So the way it works is, if you are accessing Netflix sitting in United States, then the database that is local to the country will be used to access that data, which makes it easier to access, because there is fast processing to it, because it's close to the network and many other things. Okay, let's quickly jump to the slide. So coming to the money aspect, how much do you gain by learning this topic, and how is the industry looking for distributed database versus the conventional or centralized database system management systems? Currently the conventional or centralized database management systems has more popularity and high pay in the industry right now. So that's how the stats goes. So you learn about what's the difference and what is the basic concept of distributed database management system. We'll not be getting into the networking part of it. We'll only be touching upon what is distributed database, and what are the little small things that you need to know when that word pops up anytime in your career. So as you can see here, in the centralized database management system, we'll have a database DBMS that's managing your data, and a local database which is used to query your data whenever you write a SQL query. And that's the conventional database management system that's being very popularly used even till now. And coming to the distributed, here you have this computer centralized network and different sites. So these sites can be at different countries or at different localities within the same country. And if you're doing writing a SQL query sitting in Miami, then if it's at site 2, then data from site 2 will be gathered and will be used to retrieve data. And same goes with other sites. And the problem generally comes up when you are trying to integrate everything together, and when writing a query where you're trying to gather data from all the sources, and which is when the real problem occurs. and there are different strategies to tackle that, and which we are going to talk in the next slides. So distribution transparency. Transparency itself is a word that is generally used in DDBMS jargon. So transparency is making sure that the end user who is writing a SQL query doesn't need to learn a lot. So if I'm writing a SQL select query or an update query, then, and if the architecture is a DDBMS, then it would be the same query that you generally write for a centralized database management system. So in order to make sure that there is not much of a learning curve when you're using a DDBMS, these are the transparencies that DDBMS has to follow for a smooth transmission from centralized to a distributed. So different things, different jargon, different words that you will, and I'm only going to, as I told you, few important points that I'm going to touch upon would be the fragmentation, which is a simple topic to understand and which will be easy to, which is something that you need to know when you talk about DDBMS. So as the word distributed in itself implies that the data has to be partitioned and distributed, and this distribution happens in the form of fragments, and this fragment can be replicated if it's needed to replicate, and then and you need to locate and allocate those fragments to different locations based on the requirements. So these are the three important phases while designing a DDBMS. So fragmentation is more like splitting the data into several parts, and that can be done in different ways. So I think this can be best understood by taking an example. So let's quickly go over a database table here that I created. That's earning table. This table has an earning ID, code, amount, hours, and department number and month. About 4,233 rows. So if you want to partition this table into different fragments, you can do it by a horizontal fragmentation, or a vertical, or a mixed fragmentation. So when I say horizontal in this slide here, so this is dividing the data set, a relation, into subsets of rows. So if you want to divide this based on the earning code, let's say this earning code is other, so now you have this 1900 rows, so this becomes a fragment. Fragment is a collection of rows based on an attribute. An attribute is a column here, that's the earning code, and this data will be placed at one of those sites. So let's say that in this example here, so this part, this region, this site 2 is earning code that has been split up, and this site 2 contains only the data that has an earning code other, whereas site 1 has another different earning code that's in this case is rec by. So rec by is at site 1, so that's a part of the data is at site 1 and the part of the data is in site 2, and that's how distribution happens. And in this case the distribution happened based on the rows. So I mean, it's based on a column that's earning code, but then you have the everything, all the rows or entire rows data in partitioned. So this is called as a horizontal fragmentation. In a vertical fragmentation, you will have let's go over the definition of vertical fragmentation. Division of a relation into attribute subsets. So you only have, let's say at site 1 you only have current hours and then current amount or department number. You only need these 3 columns of data, and that data will be placed at, let's say, site 2, and then the data of earning ID and earning code will be at site 1. So that's a vertical splitting, that's called as vertical fragmentation. And that this and the mixed fragmentation will be a combination of those two. That would be like at site 1, you have this other data, and then that's again further split within the other into only site 1 having current amount and current hours and department number columns, and not the other columns. So site 1 is again split into having fewer columns within the fragmented table. So that becomes so within the site 1 you only have other data, and within the other data you again further split by the columns. That becomes a mixed fragmentation. So the fragmentation depends on the requirements and how much and the processing times. So in the example of Netflix, maybe the user at United States is only looking at maybe I'm not so much of a Netflix fan. I haven't used Netflix anytime, but I'm gonna use an example that's very common. So let's say Netflix has Friends episodes that's being mostly most number of viewers. So those Friends episodes will be stored in a database that's close to the US, or where there are more number of viewers. So that's how it's fragmented. So the fragmentation depends on the users, number of users in that region, and number of customers, and the demand of that information. So that's how the fragmentation and distributed database design happens. So I haven't talked about data replication or data allocation. From the word itself, it suggests that data gets replicated. Let's say the Friends episode that I just spoke about, maybe the same thing is mostly viewed in other countries as well, like in Europe, let's say, or in Australia. Then maybe the data gets replicated in those areas as well. This fragment gets replicated in those areas. That's the replication part. And the allocation is to decide on where the demand is and where to locate these replicates and fragments. That's the data allocation part of distributed database design. So that's how it works. And looks like this Apache Cassandra is something new, and this is being developed in 2016 and being used by companies that are really trending right now, and looks like DDBMS is going to prosper in the future. And there are many other technologies which I'm going to talk about in the later videos, like blockchain, which is another interesting database